In this video, we're going to find out how to order and compare exponents. Let's start by comparing 2 cubed to 3 cubed. Well, I know that 2 cubed, when it's expanded, is 2 times 2 times 2, and 3 cubed is 3 times 3 times 3. 2 times 2 times 2 gives me 8, and 3 times 3 times 3 gives me 27. I know that 8 is smaller than 27, so that means that 2 times 2 times 2 is smaller than 3 times 3 times 3. So therefore, 2 cubed is smaller than 3 cubed. Let's try another one. 4 cubed compared to 4 squared. Well, I know that 4 cubed can be expanded into saying 4 times 4 times 4, and 4 squared would be 4 times 4. 4 times 4 times 4 would give me 64, and 4 times 4 would give me 16. I know that 64 is greater than 16, so this means that 4 times 4 times 4 is greater than 4 times 4, so therefore 4 cubed is greater than 4 squared. Do you know that there's actually a trick to comparing these exponents without needing to go through all this working out? Well, take a look. In the first comparison, the exponents are the same, but the bases are different. But in the second comparison, the bases are the same, and the exponents are different. Well, in the first example, the bigger base ended up being the bigger answer, and in the second example, the bigger exponent was the bigger answer. This leads us to some important notes. Firstly, if the exponents are the same, the bigger base is the bigger option. And then, like in our second example, if the bases are the same, then the bigger exponent is the bigger option. But what happens if the bases and exponents are all different, like in this next example? When this happens, the following rule applies. If neither the bases nor the exponents are the same, work out the value of each side and then compare the original numbers. Remember, that's what the question's asking you to do. So always go back and compare what you were originally given. So for example, we've been given 5 squared and 2 to the power of 4. I know that 5 squared expanded is 5 times 5, and 2 to the power of 4 expanded is 2 times 2 times 2 times 2. 5 times 5 is 25, and 2 times 2 times 2 times 2 is 16. I know that 25 is greater than 16, so if I work backwards, I know that 5 times 5 is greater than 2 times 2 times 2 times 2. Therefore, 5 squared is greater than 2 to the power of 4. Because a calculation was required, you would need to show these steps in order to gain full marks. The same rules can be applied when you are ordering exponents as well. Let's take a look at ascending order, which we know is from smallest to biggest. I've been given 3 cubed, 2 cubed, 10 cubed, and 7 cubed. Here, the same rule applies, so all my exponents are the same, so all I need to do is focus on the bases and order them in ascending order. So that means 2 cubed would come first, followed by 3 cubed. Then it would be 7 cubed, and the largest exponent would be 10 cubed. The same thing works for when the bases are the same, but the exponents are different. Now that the bases are the same, all you need to do is focus on the exponents and order them in ascending order. So that means the correct order here would be 7 squared, 7 to the power of 6, 7 to the power of 8, and 7 to the power of 10. Okay, let's switch it up and do some descending order, which we know is from biggest to smallest. Here I've been given 3 squared, 2 to the power of 5, 4 to the power of 1, in other words, I've just got 1 4, and 10 cubed. Nothing is the same, everything's different. So remember this important note. Work out their values and then order the original values. If the bases are all the same or if the exponents are all the same, you don't need to show any working, but in this case, nothing is the same. I'm definitely going to need to show some working. So I'm going to begin by writing out the value of each of those exponents, and I'm not going to go expanding them first because I'm actually just going to run out of space. I'm just going to write down what they would total to. So for example, 3 squared would be 9, 2 to the power of 5 is 32, 4 to the power of 1 is 4, and 10 cubed is 1,000. So if I were to put these numbers into descending order, it's really easy to see where they go. First, I'd need the 1,000, then I'd need 32, followed by 9, and ending on 4. But remember, you have to order the original exponents. So that means that instead of 1,000, I'm going to have 10 cubed in the first place. Instead of 32, I'm going to have 2 to the power of 5 in the next place. Instead of 9, I'm going to have 3 squared. And instead of 4, well, that's going to basically stay the same, isn't it? You could write 4 to the power of 1 if you wished, but 4 on its own is perfectly fine. And there we go. It really is as easy as all that.